Okay, so today we're going to talk about how you're able to solve expressions using inverse operations. Alright, so the first thing we're going to do, first of all, this is the vocabulary: equation, solution, solution sets, and inverse operations. We're going to do some do now, so I'm going to open up a different page to do that. Okay, so let's evaluate. Now, just a reminder, evaluate means to find the value for an expression. Okay, and an expression is a mathematical object that doesn't have an equal sign. Not only does it not have an equal to sign, it doesn't have an equal to sign, it doesn't have a not equal to sign, a less than symbol, a greater than symbol, a less than or equal to symbol, or a greater than or equal to symbol. It has no comparison symbols. Okay, an algebraic expression just has none of these 6 comparison symbols. So this first object is an algebraic expression. Now the first thing you do is you substitute what they want the value of x to be into the expression. So this should read 3 plus 5 times 2 squared. Alright, so you don't perform any operations, you just substitute. And then in order to figure out what operation, so I have to add, I have parentheses, within the parentheses I have to add, and then I have a 2 squared on the top. Okay, so to figure out what I have to do first, I have to refer to Pemdas, and that's why it's up here. So Pemdas says to do parentheses first, and then to do exponents, and then multiplication and division from left to right, and addition and subtraction from left to right. Okay, so I would do parentheses first, so 3 plus 5 is 8. I'd bring down the 2 squared, and then 2 squared is 4, so I'd have 8 times 4, and I bring it down in this funnel shape. Okay, and 8 times 4 is 32. Okay, and then I circle my final answer. Alright, for the next one, I would again substitute first. And then actually, the one thing that you should know about the square root, the principal square root, right, that's the positive square root, is that that is done at the same time you do exponents, because it's considered a type of exponent. A root is a type of exponent, because you can you could rewrite the square root of 4 actually as 4 to the 1/2 using a fractional exponent. Okay, so you have 3 squared, which is 9, all right, and 7. I'm going to replace the principal square root of 4 with 2. That's 7 times 2. Then I have to do multiplication first, according to Pemdas. So I have 9 times 14. Okay, and I'm actually going to bring it over here. A little bit of space over here. Okay. So I have 9 minus 14. I'm going to use KCC, or keep change change. Turn this into 9 plus negative 14, and that would be negative 5. Okay. Now the reason why I gave you these 2 examples is because when we evaluate expressions, we use PEMDAS as PEM, M and D, and A and S. Okay. We're talking about solving equations today. So first of all, let's define that. Okay. An equation is a sentence with an equal sign. Okay, a sentence with an equal to symbol. Let's see here. That states that 2 algebraic expressions are equal. So for instance, if I had x squared plus 1, that's an algebraic expression. I have another algebraic expression like x plus 4. An equation sets those 2 equal. Okay, so this whole thing is a type of equations. It is an example of an equation. When we solve equations, first of all, we only use the word solve when we talk about equations. We never ever solve expressions. That's not used for expressions. This verb solving means to find the value of x that makes this equation work. Okay, and so what we have to do is we have to think about where this x is. Okay, so let's look at the example number 1. You have 6 times x minus 7. Now the first thing that you do is you start to and you've sort of been trained to do this, and it's not you have to sort of forget what you're doing, but the first thing you start to do is you try to think about the numbers that you would put in there. So maybe you would substitute 1 in there, right? You just look at the right hand side of that equation and you say, okay, well, what if I put 1 in there? Okay, well then that would be 6 minus 7, and that's negative 1, so you know 1's not there. So what you're doing is you're using a guess and check method. Alright, and that was okay in 6th grade. It is definitely not okay in algebra. Algebra asks the question about, how do you undo all the things that were done to x in order to arrive at what x was before you multiplied it by 6 and subtracted 7. Okay, so you have to get rid of that that instinct that you want to start putting numbers in for x and substituting it in to see, what the answer might, what value of x is going to make this equation true, right? That's not an algebraic instinct. So let's just look for a second, though, at the way that we tried to put 1 in here. Okay. Now the first thing that we did was we multiplied by 6 and then we subtracted 7. Okay. Now when we solve equations, this is what you would do if you were evaluating an expression. But when you solve equations, you want to undo those operations. Right? So when you undo something, you work in the reverse direction. So if I went here in one direction, the first step I would have to take would be working backwards this way. So I'm literally using the reverse of PEMDAS. So I like to call it SADMAP. Right? First get rid of subtraction and addition from left to right. Then get rid of multiplication or division and multiplication, doesn't really matter, from left to right. And then you want to get rid of exponents, and then you want to get rid of parentheses. Okay, that's the order that you're going to do them in. So since I have two of these, I'm just going to erase this right here so I have more room. I have two operations to work with here. Okay, I have trying to get rid of subtraction and trying to get rid of the multiplication that binds the 6 to the x. I'm going to choose to get rid of the subtraction first. Okay, and essentially I'm asking the question, what was 6x before you subtracted 7? All right, so you know that 6x minus 7 is 1. Well, what was it before you subtracted 7? So if I add 7 to both sides, okay, I'm doing the vertical addition method here. So I bring down the 6x, and 1 plus 7 is 8. Okay, now let's just erase this so we have room. So I have 8 is equal to 6x. Now, what you want to do is you want to divide by 6 from both sides. All right, this is the fraction bar, not the subtraction bar, but that's the fraction bar. You have x is equal to, now let's reduce this a little bit. So 8 and 6 share a common factor of 2, so it's 4 over 3, which is 1 and 1/3. So x is equal to 1 and 1/3. And it's fine to leave it like that. And if you wanted to, you could put that back into the equation right there, so you can check yourself. So you could say 1 is equal to 6 times 1 and 1/3. I'm going to put it as 4/3. I'm going to leave that as 4/3 so that I can multiply it by 6 more easily. 1 is equal to, let's put 6 over 1 here. Okay, so before we even multiply that fraction out, let's reduce. So 6 and 3 share a factor of 3. Divide that by 3, I get 2. Divide this by 3, I get 1. So let's just make sure the left-hand side is still 1. And over on the right-hand side, I'd have 8 over 1. Well, 8 over 1 is just 1. So I just have 8 minus 7. And that's certainly true. So 1 is equal to 1. Okay. So because I arrived at a true statement, it must mean that those are, that was the correct answer. Right? And that's the same as this one. Okay, so example number 2 is 8x plus 5 is equal to 21. Okay, now I have multiplication between the 8 and the x, and then I have addition between the 8x and the 5. So I want to remember I'm using SADMAP. So subtraction and addition, get rid of first, then multiplication and division, and then any exponents, and then any parentheses. All right, so the first thing to do is I want to get rid of this addition, so I want to subtract 5 from both sides. Now I'm drawing the subtraction bar. It's different from a fraction bar. Okay, I bring down the 8x, because really, by the way, all this lines up. That's 8x plus 5 minus 5. Well, remember, if you're really adding 5 and subtracting 5, that's just 0, because they're added the opposite inverse operation. So that's what you have left on the left-hand side is 8x. Okay, and then 21 minus 5 is 16. Now let's break the isolate the variable by using the inverse operation for multiplication, which is division. Okay, 8x divided by 8 is just 1x, and 16 divided by 8 is 2. Okay, well, 1 times x is just x. So really, you didn't actually have to do that step. I just like to show that step sometimes. And you can certainly put that back in to check. 8 times 2 plus 5 should be equal to 21. That's 16 plus 5 is equal to 21, and indeed, that is right. Okay? Okay, the next example is 15 minus 3t is equal to 24. Now, the other two examples were a little easier. This is a little harder because the term with your x in it, has is the subtrahend of a subtraction problem. All right, and you can't just take 15. You can't subtract 15 away from both sides, because if you did that, you'd be bringing down that subtraction symbol, and you really aren't allowed to subtract 3t from something where you don't. What are you subtracting 3t from? Would be the question, right? So you can't take away a minuend and leave a subtrahend. All right, so we have to think about something else to do. So there's a couple different ways you can do this. I'm going to show two techniques. The first technique, which you might like, is adding 3t to both sides. Okay. You have 15 on the left-hand side. You bring this, ends up being 0. Now 24 and 3t don't add together, so you just rewrite them as 24 plus 3t. Right? They're unlike terms, so they don't add together. You can't combine them. Now you on the right-hand side you have addition, and that's perfectly fine to take away one of the add-ins. Okay, so I can take away 24. It's fine to leave 3t by itself in this situation. Take away 24, bring down the 3t. Now 15 minus 24, okay, use keep, change, it would be 15 plus negative 24, and that ends up being, let's see, 24 minus 15 is 9, so that would be negative 9. Okay, so you have negative 9 there. Now to get rid of the multiplication, let's divide by 3. Okay, and so you'd have t is equal to negative 3. And that's the answer. You could check that. Okay, another way of solving it, so let's go back to our original problem here. We'd have 15 minus 3t is equal to 24. Another way of doing it is you can use just keep, change on the left-hand side. So you might like this a little better. So you have 15 plus negative 3t is equal to 24. And then you don't have a subtraction symbol anymore. That's just the negative sign in front of the 3t. Okay, now it's perfectly fine for you to subtract 15 from both sides, because you're not leaving a subtrahend without a minuend. All right, and it's super important not to do that, because that's just not an allowable move when you're solving equations. So here you can subtract 15. All right, you have negative 3t is equal to, that's 9. Notice that this situation right here is very similar to this one right here. Okay, except you have negative 3t is equal to 9, and on the left-hand side you have negative 9 is equal to 3t. But notice that in just a second I'm going to show you that they come out to the same thing in the end. Divide by negative 3, t is equal to a positive divided by a negative is a negative. So same thing, identical thing. So you're allowed to use either strategy to do these problems. Okay, so the next problem, we have y over 5 plus 3 is equal to negative 2. Okay, remember that the other thing I didn't say really is that if you don't like if you don't like the sides that the expression and the constants are on, you can always change them. Right, those two are the left-hand side and the right-hand side are identical. Okay, all right. So y is being attached to 5 with division, and then attached to 3 with addition. Okay, now notice that if you were to just concentrate for a second, let's forget about this equation for just a second. Let's just think about this. Pretend this is an expression, and I asked you to evaluate it. Let's say I say y is equal to, I don't know, let's make it easy, 10. Okay, well, the first thing you do is you'd substitute, and the next thing you do is try to figure out what you do first. 10 divided by 5, or do you add 3? Okay, and it turns out that this is you're supposed to do 10 divided by 5 first and then add 3. Well, how do you know you're not supposed to add 3 first? Because if they wanted to take the sum of 10 and 3 and divide that by 5, then you would have written those two things in the numerator of a fraction. Okay, this right here says first you add 3 and then divide by 5. This right here says take 10, divide it by 5, and then add 3. Alright, so this is all sort of a side problem because we're not dealing with an expression. We, in fact, have an equation. But this gives us insight into how we're going to solve this equation. So when we were evaluating, the first thing we did was we divided by 5. So, and then we added 3. So since adding 3 was the last thing that we did, that's the first thing that we're going to try to unravel when we're dealing with solving equations. So the order in which you evaluate an expression is the reverse order in which you want to solve equations. Okay, so you want to subtract 3 from both sides. Have y over 5 on this side. Now be careful with this this problem. Write it horizontally first. Okay, a lot of people think this is -2 minus -3, and this is not. That's a minus sign. That's not the sign of 3. That's a minus symbol. It's not a negative sign. So use keep change. That would be -2 plus -3. That ends up being -5. Okay. Okay, so I'm just going to erase that right there. Now the next step is I have to try to get rid of the division here. So in order to do that, one way of looking at, one thing that people really like to do is they like to think of these as proportions. Proportions are fractions that are set equal to each other. So I have a fraction on one side. To make a fraction on the other side, I can just put it over 1. Okay, I'm going to erase over here so that I have more room. Now, okay, once I have this right here, I have y over 5 is equal to -5 over 1. Now my cross products are equal to each other. Okay, y times 1 is y, and 5 times -5 is -25. And I've solved it. That's it. Y is equal to -25. And if you put that back into the equation, you would see that that works. Alright, if you don't like making things into a proportion, okay, let's go back to this part right here. If you don't like making things into a proportion, so what do we have? We have y over 5 equals -5. Another way you could do it is multiply this side by 5, multiply this side by 5 because you did it on the left-hand side. Well, over on this hand side, you'd have to, because this thing is a fraction, you'd have to make this thing into a fraction. Then you multiply by the numerator, so you have 5y. 1 times 5 is 5. That's equal to, here is -25. But what's 5y over 5? That's just 1y, which is y, is equal to -25. So you arrive at the same answer. So whether you make it into a proportion or whether you just multiply by the reciprocal of what's in the, or you multiply by something to get rid of the denominator here, those are both acceptable strategies. Okay, the next example has a strategy that I'm going to use a strategy that we just showed, which is making it into a proportion. Okay, so you have a fraction on the left-hand side. Let's make a fraction on the right-hand side. Okay, then we can use cross products. So 6 minus 2x times 1 is 6 minus 2x, and 4 times 3 is 12. Okay, and then we just have an equation like example number 3, I think it was, where the term with the variable is the subtrahend of a subtraction problem. So again, you at this point can pick either adding 2x to both sides, or you can change it into addition. Okay, then you'd subtract the 12. You'd have, I'm going to bring it over here, you'd have 2x on this side is equal to 6 minus 12 is -6. Then divide by 2, x is equal to -3. Okay. You could have also alternately, instead of doing it this way, you could have used keep change here. Okay, and then you would have had, 6 plus negative 2x, and then you could have subtracted 6 from both sides. You'd bring negative 2x down, and then that would be 6. You'd still divide by negative 2, and you'd come up with the same thing. Okay, that one's the same as the one over here. Okay, example number 6 has 1/3 w plus 6 is equal to negative 2. That's different from the 6x minus 2 over 3 that we had in the last equation, because this means the entire numerator has to be divided by 3. So the first thing I would have done is, another strategy you could have used was multiplying by 3 to both sides, and that would cancel the denominator there. But here, this is different because that's the 1/3 is the coefficient to the w. It's not the 6 is not being divided by 3 here. So we try to get rid of addition first. We're going to do that by subtracting. So you bring down the 1/3 w is equal to. Now let's write this out horizontally so that we don't make a mistake. So that's negative 2 plus negative 6, which is negative 8. Okay. Now let's pick a different color here. I have this 1/3. Now what I really want is 1w, because once I have 1w, that's just w. What do I multiply 1/3 by in order to get 1? Well, let's just multiply by its reciprocal. Now over on the left hand side, I chose to write it as 3 over 1 because I know that I'm going to be multiplying by a fraction. But on the right hand side, I chose to write it as a whole number because I'm going to be multiplying by another whole number, and that's perfectly fine. So 3 times 1 is 3. And then 1 times 3 is 3. W is equal to negative 24. Well, 3 over 3 is just 1. So you have 1w. Well, 1w is just w. Okay? I haven't been checking the work just to keep this video short, but it's a good idea for you to check your work in some other area of the workspace. Okay, now we have an equation that has a decimal in it. All right. So let's just deal with that in a minute. We have multiplication between 0.8 and r, and we have addition of 19. So let's get rid of the addition first by subtracting. Okay, I'm going to bring down the 0.8r, and over here on the right hand side I have 1. Now sometimes I like to change, I'm a big fraction person, so I like to change things into fractions. So 0.8 is the same as 8 over 10, right? Because 0.8, this is the tenths position, right? So I have 8 in the tenths position. That's the same as the fraction 8 over 10, which is actually, if I want to reduce it, it's the same as, 4 over 5, right? Because they both share a factor of 2. 8 and 10 share a factor of 2. So I have 8 over 10, r is equal to 1. Well, we're going to use the same trick that we did in the last slide, which is, I don't want an 8 over 10 r. I want 1 r. So how do I, oh, I just reduced it and then I didn't use the reduction, did I? So let's just write this as 4/5 r. It's a little bit better. Okay, I don't want 4/5 r. I want 1 r. Okay, so one way of getting 1 as a coefficient to r is multiplying 4/5 by its reciprocal. And of course, what I do to one side, I have to do to the other side. I've been sort of multiplying the fractions out, but one of the techniques is to reduce the fractions before you multiply. Reducing fractions mean you try to find a common factor between the numerator and denominator of the fractions before you multiply. So 5 and 5 share a factor of 5. Divide each of them by 1. 4 and 4 share a factor of 1. Well, over right here, that's just equal to 1 over 1, which is 1r. And then 1 times 5 over 4 is just 5 over 4. So you have r is equal to, now let's change this into a mixed number. You don't have to change it into a mixed number. I just sort of get in the habit of doing that. Okay, and that's the end of the video.